DBA class could be a full semester class. As you know, the book you've got is 50% development, 50% DBA. And so far, we've spent an entire semester on development stuff. We could easily do a full semester on DBA. Fortunately, the school doesn't really have that class. But as you can see, there's a lot of commands and we're not even through yet. The DBA. Show tables, we've used that command before. Triggers are useful too. We just did a trigger exercise. So it show you all the insert triggers. I guess I don't have any. Show warnings is like show errors. If you have a warning on a command, it'll show you it. Some other administrative commands, cache, index. That's putting an index, caching it. Hold on for a second. Assigns table indexes to specific key cache. It's only used for MyISAM. I've never used that. Flush is useful sometimes. That's basically flushing what's in various memory buffers out to disk. Generally what that is. So we did flush privileges earlier. Reloads the privileges from the MySQL database. Kill command will kill a connection. You have to know the thread. In Unix, that's pretty easy. You use the process ps command. Not exactly sure how you do that in Windows, actually. Replication we're going to talk about later on. I'm not going to get into replication just now. That's next week. This all has to do with replication, changing master. This is all to do with replication. We'll talk about that next week. Yeah, this is all replication. Let's see, so far it's all replication. Yeah, that's still replication. Prepared statements. Now we've talked about prepared statements. We've gone over prepared statements quite a bit. We've already done this. We've done prepared statements in the stored procedure language. We've done it in Java. and we've done it in PHP. So we've already done stored prepared statements. All right. Let's see. Okay, I think we did all this. We haven't looked at creating a database yet. So let's look at creating a database is pretty straightforward. You just say, so we should look show databases. And that's what we got. Creating a database is pretty simple. You just say create database and whatever you want to call it. Let's say CSM. Done. Show databases, now show CSM. Show tables. In the test database, we got a bunch of them. If I switch to the CSM database I just created, and then do show tables, there's no tables. It's a brand new database, which is generally a good idea. You generally would create a separate database for each distinct application that you want. And once you're in there, now you can create a table. Test ID int value varchar 255. In there, now if you say show tables, got the one table. So it's generally a good idea to create separate databases for distinct applications. Getting rid of a database is fairly simple as well. You just say drop database name, create table, create index. I'll talk a little more about indexes a little bit later. I think we've already talked about indexes, but I'll talk about it a little bit more. Alter databases if you want to change something about the database. But you wouldn't generally use the alter. Oh, that's the alter table. Alter database. Alter database. So you could. There's not much you change about a database. You can change some of the character sets and stuff. That's about it. Alter table, which we've used, you can do all kinds of things. You can add columns. We had exercises where we add columns, primary keys. You've got all kinds of options of things you can do with the alter table, and we've used that command a few times already. Database, create index. I'm talking about indexes a little bit later. Create table we've used, drop database. I talked about it. I could drop that database if I want. Talk about indexes in a moment. Drop table, that just deletes the table. We've used that before. Rename table, we talked about that as well. Okay, so let's go on to indexes. Indexes are also a very important, creating indexes and maintaining indexes are also a very important thing that a DBA does, because this is directly related to performance. And I think we've talked about indexes, about why you want to create them. Indexes, for the most part, are there to improve performance or to increase speed. They work on the concept of something called a binary search. A binary search is simply where you cut the list in half, and I think we've. Let's see. Let's go ahead and take a look at this. This here, I think, is a document. I don't know if I want to go through it. Oh, this is actually a C code thing of how to implement a binary search using nodes and stuff. I don't know that I really want to go over that. If you really want to look at technical, let's see. This is back from when I taught C. Actually implemented something called a linked list. Most indexes are implemented using something called a linked list. And it's a binary tree. It looks a little like this, and basically there's data over here, Adams, and let's say you're looking for Donaldson, and it says, okay, is Donaldson greater or less than Adams? It's great. Well, actually, you really don't have much of a choice. It keeps on going down the list. It's greater than Brown. It's greater than Clinton. So it goes to the right side. When it's greater, it goes to the right side. When it's less, it goes to the left side. Right? So greater than Adams goes to the right. Greater than Brown goes to the right. Greater than Clinton goes to the right. Let's say we were looking for Carter. So greater than Adams goes to the right. Greater than Brown goes to the right. So it cuts the list in half every time. In this particular case, it's a small list. But in a million row database, and I think I may have another handout for that. Let's see if I have that or not. Binary search. No, this is not. This is pretty much the same thing. Okay. All right. Well, actually, here is a description of basically what a binary search is. So let's say you start with 1,000,000 rows. The first check cuts the list in half, 500,000. The next one cuts it in half, 250, 125, and it keeps cutting the list in half until it eventually finds a match around after roughly 20 searches or so on 1,000,000 rows. And that would be worst case scenario. So